In this video, you are going to learn how to determine if a relation is a function. So first thing you just need to remember is a relation can be represented by a set of values. The domain is a set of all x values, and the range is a set of all y values. The independent variable is the same as your x values, which is the domain, and the dependent value is the same as your y values and your range. The way I remember it is domain D and X come before R and Y in the alphabet. A relation is a function if for each X value there's exactly one Y value. Each value in the domain of a function is called an input, and the corresponding value for the range is output. So we just want to make a little chart. X is our domain and input. Y is our range and output. And then you can think of input independent, output dependent. Alright, just some ways you can see a relation in ordered pairs, in a table, in a mapping, or somewhere on a graph. So they ask you to state the domain and range of this relation, which is a set of ordered pairs. Remember, your domain are all your x values and your range is all your y's. So I'm first going to look at all my x values here. 1, 2, 3, 4. That is my domain, is 1, 2, 3, and 4. Now my range is 3, 4, 3, 4. I don't need to write them twice, so my range is just 3, 4. Now here, this relation is not a function, and you're going to learn soon on the next page, but see how 2 goes to 2 values? That's not allowed to be a function. But first we're just going to look, our values over here are x, and our values over here are y. So negative 1, 2, 3. Our y values here are 2, 4, and 6, so my range is 2, 4, 6. When you are looking at a graph, it's a whole lot easier to figure out what the point values are. So this guy's at 1, 1. I'm just going to cross them off because I did it already. This guy's at 1, 2, 2, 1, 2, 2, and 3, 3. Again, this will not be a function because it doesn't pass your vertical line test. There's more than one x value. But my domain here is 1, 2, and 3. You don't have to write your values twice. And the same thing here, 1, 2, and 3 for your range, since these are my x's and these are my y's. Alright, try the last one by yourself. I'm going to fill it in. Okay. Now on this side we are determining whether the relation is a function, and then we just explain why or why not. To determine if it's a function, we look at our x values. X values cannot repeat. So I have a negative 5, a 0, a 0, and a 3. And if you noticed, I repeated my zeros. So not a function. Let's look at our second set. Our x's are 2, 6, 1, and negative 1. It is a function. No x repeats itself. When we look at our last one, we have a double 3. So my 3's repeat. So not a function. Okay. When given a graph of a relation and if it's asked if it's a function, the vertical line test is used. VLT you can write for short. If more than one point shows up on that line, then it is not a function. So, if I use a piece of paper, I'm going to pretend the end of my post-it note here is the vertical line, and I move it across. I hit my first point, no other point falls on it. Do it for the second again, and I keep moving, and there was no point that fell twice on my vertical line. So this guy is a function. Now let's look at our second one. If I do the same, that first point's good, but when I look at that second one, do you see how 2 points fell on that line? Not a function. Do the same thing for the third. I have a ton here that fall double on the lines. Here's one here. So not a function. When I look at my last one, no point hits twice, so it is a function. You can pause the video and try the bottom part by itself. If not, just work with me here. Alright, so we're determining whether the mapping diagrams or tables represent a function, and I'm circling yes or no. So I look at the input, because my input are my x's. 1, 3, negative 2, and 5 only have one arrow coming out of it, so yes, it's a function. Number 2, do you notice how 3 has 2 points coming out? So no, it is not a function. Number 12, I only have one coming on negative 4, one coming on negative 1, 0, 5, so yes, a function. It's okay that they both go to 7. 7 are my y's. It's fine. Look at my next one. None of my x repeat, so yes, it's a function. Look at my inputs, which we talked about being our x. I have 4 twice. No, not a function. When I look at my last one, 1, negative 2, 3, and negative 5, yes, a function. Let me know if you have any questions.